Hey guys, welcome. This is our linear inequalities video. So just write linear inequalities at the top, and then we're going to write all of this right underneath it. And let's go ahead and get started and talk about what is a linear inequality. We've talked about linear equations, and a linear equation would be an example of this right here. If I were to kind of show it to you, where we just draw a line, and it's an equation. So the values of the equation are on that line. A linear inequality, however, is a little different. So if we read, it says a linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as a set of all points on one side of a boundary line. So we're going to go ahead and take a look at what that means. Basically, we're going to be drawing a line like we did with the linear equation, but then we're going to shade up, or we're going to shade down, left or right, depending, and it's going to include all of those values up to that boundary line that we graph. Let's go ahead and take a look at some examples. Okay, first example, it's asking, is this ordered pair a solution of this graph? So we're not even graphing it, we're just saying, is this ordered pair a solution? So we take x comma y, and we just plug it in and say, does this work out? So we're going to get, instead of y, we get the value of 2 greater than 1 minus 3, so we get negative 2. And we got to ask ourselves, is 2 bigger than negative 2? Is that a true statement? Inequalities have more than one statement. In this case, this is true, so we would say yes, 1 comma 2 is an ordered pair. So that just means that we have an ordered pair. We're good to go. Okay, let's go ahead and move on to another problem. Okay. Let's go ahead, and this is going to be our second problem here, so make sure you write number 2. What is the graph of y is less than or equal to 1/2 x plus 1? Okay, so we actually treat this like we're going to graph it normally. So I'm going to draw a graph, coordinate plane, and we're going to pretend like we're just graphing a normal line. And y equals mx plus b. It's in this form, except for we have this inequality, which we'll deal with in a second. But we're going to first graph it like this. So we're going to start at 1 on the y, and we're going to use our slope of 1/2. So we're going to go up 1 over 2, up 1 over 2, and I'm going to have some sort of graph that goes along like this. Now the inequality tells me how I'm going to graph. So I want you to go ahead and write this out. We're going to do this sign with this sign. And then we're going to do this sign with this sign. Okay. Now, if there is no equal bar, it's going to be a dashed line. So this is dashed. This is solid. This is dash. And this is solid. Okay, so first we got to ask ourselves, am I going to have a dashed line or a solid line? So I see that there's an equal bar on this one, so we're going to look at this sign right here. And there's an equal bar there, so that means I must have a solid line. So I'm just going to go ahead and draw a solid line. Okay, next. I can actually put these into a box. Hopefully you put this somewhere a little bit better. This sign means less than. So y is less than. We're going to shade below for both of these. Shade below. And maybe if you spell correctly. Let's try that one more time. And this is greater than, so we're going to shade above. Okay. And we have a less than sign, so we're going to actually shade below. So that means anything shaded below this line is actually a solution. I can plug any point. I could pick a point right. Let's do black. No, let's do blue, and let's make it thick. I could pick this point here, this point here, this point here, this point here. All of these are solutions to our equation. So that's what it should look like. Now, it gives me some answer choices. Let's see if we can look at those. Now, we know what it kind of looks like. I'm going to erase it now. Whoop. And now let's go ahead and take a look at some of our answer choices. Okay. Notice all the graphs are the same. They're graphed at 1. They go up 1 over 2, up 1 over 2. but we have a solid line, so we know that we are not going to use the dash line one. So these are out. And we're shading less than, so we're going to shade below. So D is our correct answer. Okay? So those are all the different types that we could potentially see. Let's look at one more. Okay, this one we see is slightly different. We've had some kids get into some trouble with these when they're by themselves. So we have x is greater than -1. So first we have to draw basically, if we can, the x equals -1 line. So what is x equals -1? I wanted to do that in black, so let's try that again. And so let's first put in, sorry, -1, not 1, that doesn't make sense. Let's put in a couple points, or dashes. Okay, so x equals -1, that's going to be right here on the x. Okay, now we normally would draw a line up and down. This is a vertical line. But notice, we're not going to draw a solid line, we're going to do a dashed line. And it's greater than, so we are going to actually shade to the larger side. So any value over here will work. And this makes sense. X has to be greater than -1, which means could x be 1? Could it be 4? Could it be 0? Yeah. Could x be -2? -2 is not bigger than -1, so that wouldn't work. So we can also do it with single variables where we don't have two things to graph, but just vertical or horizontal looking lines. Okay, we'll talk about this more as we meet with one another.